Yeah, I want to look at this specific example of a study that came out of the Mariner 9 mission, because it really kind of ties together some of the important questions that came out of the telescope era of Mars, and was addressed using space age kinds of tools. Okay, so again, here's Mars. What do you see? Well, we see some of the geological features. We've got, Valles Marineris. We've got these volcanoes. We've got Olympus Mons. What do you see around Olympus Mons there? What's that?
Clouds.
Clouds. Okay. So clouds were known from the time of telescope observations of Mars. We know, this is clearly better data than would have ever been available to Herschel and Beer and Schiaparelli and Lowell. These are our Hubble images showing Mars a few weeks apart. Why are the features much more obscured in the later picture?
The storm.
Global dust storm, okay, 2001. So one of the actual experiments or studies that was done from the Mariner 9 data is to address the question, we see these clouds on Mars, we've seen them for a long time. Do we have any evidence? Can we find any evidence that those clouds actually represent water ice? And what? Yeah. Here's the abstract of the article. Most of the times when you write up a scientific paper, you present an abstract at the beginning to let other researchers know what's the nuts and bolts of the paper. We're all overrun by scientific literature. There's so much scientific literature being produced that oftentimes all you do is read the title. If the title interests you enough, you might read the abstract to know whether or not you actually need to spend the time to read the whole article. So spectral features observed with the Mariner 9 interferometer spectrometer are identified as those of water ice. The measured spectra are compared with theoretical calculations for the transfer of radiation through clouds of ice particles with variations in size distribution and integrated cloud mass. Comparisons with an observed spectrum from the Tharsis Ridge region indicate water ice clouds composed of particles with a mean radius of 2 micrometers and an integrated cloud mass of 5 times 10 to the minus 5th gram per square centimeter. It's a mouthful probably for most of you, but what do you think the study's about? What are they trying to do? Looking for water. What forms of water in particular are they looking for? Okay, so we see these clouds. I'll have a slide showing this in just a minute. But the clouds could be a whole variety of things. And we need to be able to tell how we can actually tell what those clouds are made of. And we're probably interested in whether there are water ice clouds, because if there's water ice in those clouds, that means something about the water availability on Mars, and we're just generally interested in water on Mars for a variety of reasons. Okay, so question, Martian clouds. We have for decades, more than a century, seen yellow clouds and white clouds, and the observations from the ground kind of associate the yellow clouds with being dust clouds, dust storms. But the white clouds, what could those be? There are a variety of volatiles that could produce clouds in the Martian atmosphere. They could be water ice, and we'd be interested. What other kinds of volatiles could make clouds in the Martian atmosphere, though? What do you know that's in the Martian atmosphere? Carbon dioxide. So maybe they're carbon dioxide ice clouds. Ammonia can make clouds. Mars would be quite a bit different place if these white clouds were ammonia clouds than if they were water ice clouds, right? So just because we see white clouds and we know that white clouds on the Earth are water does not mean we can necessarily directly apply that to Mars without some kind of test. Now, Mariner 9 is an orbiter. Is it directly encountering clouds in the atmosphere? No. Does it have a big long scoop to reach down in the atmosphere and pick up a sample of clouds in order to do, no. So Mariner 9 has to do some kind of remote sensing to tell what those clouds are made out of. And remote sensing is an important concept for you to wrap your head around. I mean, remote sensing is how we track a lot of what's going on with climate and water cycles and so forth on the Earth. We've got satellites. NOAA and NASA and the European Space Agency and so forth have satellites up in orbit. And through remote sensing, we're able to track what's going on with water cycles and things like that. I'm not going to take the time to look at this at all, but basically, if you look at electromagnetic radiation, there's a whole spectrum from radio on the one end all the way to gamma rays on the other. And the visible light that we see is just, this very narrow range in the middle that are the appropriate wavelength and energy to excite the pigments in our eyes such that we can detect the visible light. Infrared radiation, for a variety of reasons, is very useful for determining the composition of materials. Different minerals, as I said, different gases will absorb and give off different heat signatures. They'll absorb different wavelengths of infrared radiation, and they will emit different wavelengths. And so we can use that as kind of a fingerprint to detect what gases or minerals are present in the environment without actually going up and directly sampling. And this is why, and I'm not going to go into it, but basically everything absorbs heat and gives off heat in different wavelengths based on how the atoms are moving around in the molecules. So can you tell the difference between this curve? I should use a laser pointer here. This curve looks different than this curve, correct? There are emissions of infrared radiation in some wavelengths and absorption in others, and water vapor and carbon dioxide look distinctly different in how they absorb and give off infrared radiation. So if we had an infrared spectrometer on Mariner 9, we could sample the infrared light coming off the planet, and we'd be able to tell the difference between carbon dioxide and water. Oh, actually, we do have an infrared spectrometer on Mariner 9. So that's essentially what this article using the infrared interferometer spectrometer. Basically, looking at the heat signature of these clouds to tell, is it ammonia? Is it water ice? Is it carbon dioxide ice? Is it water vapor? We don't think it's water vapor given the temperature conditions of the atmosphere, but okay. So they use the spectrometer to collect light from two areas. Collected light from here and they collected light from here, infrared light. And by collected here, basically the infrared spectrometer cannot determine within this circle one point for another. all it can do is take a big sample and observe it. So why did they take light from this region if they're interested in knowing what the white clouds are made of?
It's a pretty big chunk of the white cloud right there.
You got a lot of white cloud in this area. Okay, so most of what the detector is detecting when it looks here is white cloud. So it can do a spectrum, see where light is, infrared radiation is being absorbed, where it's being released, and much of that is going to be due to white cloud. Why then take a spectrum from here?
Because it doesn't have much white cloud.
Doesn't have much white cloud. So it would be the difference between these two that would tell you what the white clouds are made of. This is classic remote sensing. I cannot go down and collect white cloud material, but I can look at the infrared light given off by it, and I can compare that to the infrared light that's coming off just regular atmosphere that doesn't have white cloud. Okay, so again, the sample taken from Arcadia was basically no white cloud. And that essentially functions as the control. This is what the atmosphere does to your infrared light when there isn't any white cloud around. And that is this graph here. So what does the atmosphere of Mars do to infrared radiation when there's not white cloud around?
Takes the brightness down.
It absorbs in here, whether there's white cloud or not. And that's basically showing you that there's carbon dioxide everywhere, carbon dioxide gas everywhere in the atmosphere of Mars. Do you see any difference between the top spectrum and the spectrum here for the Tharsis Ridge area where the white cloud was? Subtle. It's subtle compared to this huge big dip that carbon dioxide gas created. But if you look here along the shoulder, you can see that in this area, now the curves themselves are just offset so you can see the difference between one and the other. This is not real difference over here. This is just, I need to shift the curves so I can see them. But you can see here in this area, the curve for the area that the white clouds are in is more depressed than just that arbitrary shift. And that corresponds to an area where we know that water ice absorbs infrared radiation. Okay. So, I mean, it's a little bit complicated looking at and interpreting the graphs, but by comparing this area where there's no white clouds with this area where there is white clouds, the infrared spectrometer can provide evidence that, yes, indeed, those white clouds do contain water ice. It's not ammonia. It's not, carbon dioxide ice. It is actually water ice that has, that's generating those white clouds. Those white clouds that people have been looking at and wondering about for 80, 90 years. Okay.